In this presentation, we'll be looking at how we manage access to our networks using access control lists. An access list is a set of conditions that controls access both to and from a network segment. There are two types of access lists, standard and extended. Standard IP access list checks the source address of packets that could be routed. This result permits or denies output for an entire protocol suite based on the network, the subnet, or the host address. Packets coming into Ethernet 0 are checked for an address and protocol. If permitted, the packets are outputted through serial 0, which is grouped to the access list. If the packets are denied, all the packets for that given category are dropped. Extended access list checks for both the source and the destination packet addresses. It can also check for specific protocols, port numbers, and other parameters. It also permits or denies with more granularity, and this allows administrators more flexibility to describe what checking the access list will do. Packets can be permitted or denied output based on where the packet originated from and on its final destination. Now here's some of what you need to know about access lists. Access list statements operate in a sequential logical order. They evaluate packets from the top down. If a packet header and access list statement match, the packet skips the rest of the statements. If a condition match is true, the packet is permitted or denied. There can only be one access list per protocol per interface, and there is an implicit deny at the end of each access list. If a packet can't match up to any lines in the access list, it'll be discarded. Now let's look at the syntax to help understand how access lists work. Let's begin with the syntax for a standard IP access list, breaking it down a section at a time. The first entry, the access list command, tells the router what you're about to do. Next, you assign a list a number. These numbers are important as they not only differentiate the access list on the router, they also tell the router what kind of access list you're creating. After choosing the access number, you need to decide whether you're going to create or permit a denied list. In the next step, you have one of three options. You could use the any command to permit or deny any host, or you could use an IP address to specify or match a specific network or IP host, or use the host command to specify a specific host only. We're using an IP address to specify or match a specific network address to the access list conditions. And the last number is the wildcard. The wildcard works like the subnet mask but in reverse. So 0.0.0.0 tells the access list to match all 4 octets of the IP exactly. This allows you to block entire subnets instead of just one host. Extended access lists have a more complex syntax because of the flexibility they allow for in blocking traffic. Here's an example of an extended access list. The first 3 fields are the same as that of a standard access list. The protocol field tells the router what protocol to filter for. Some other examples would be ICMP, IP, or UDP. The source and destination fields allow you to specify a dotted IP address in the form of A, B, C, D, or the qualifiers any for any source or destination host, or host A, B, C, D for a single host. The next field allows you to filter by port number. The EQ and the number tells the router to filter the specified port. Let's look at how and why access lists are numbered. The numbers 1 through 99 denote a standard IP access list, and 100 through 199 denote extended IP access list. By using access numbers 1 through 99, you tell the router that you want to create a standard IP access list. The numbers 100 through 199 tells the router that you want to configure an extended IP access list. So the different access list numbers just tells the router that you want to configure a filter for your network for a specific type of protocol. Let's review some specifics about access lists on routers. Standard IP list test conditions of all IP packets from source addresses and are numbered 1 through 99. Extended lists can test conditions of source and destination addresses, specific TCP/IP protocols, and destination ports. And wildcard bits show how to check the corresponding addresses. Zeros check, ones ignore. This should get you started on access list, and in the next series of videos we'll look at how to configure a standard and extended IP access list on a Cisco 2500 series router.